Okay, so today we're going to talk a little bit about microcontrollers. We're going to start with a quick review of what we talked about last time, which was computer-aided design assemblies. So we'll review that briefly. Then we'll go on to our main topic. So we'll discuss microcontrollers. We'll talk about what they are, why they're so important to robotics. We'll see some of the components that are inside of most microcontrollers, talk about what those are. Then we'll talk about the specific microcontroller that we're going to use in this class, which is called a propeller. We'll talk about why we chose that one and what makes it special. And then we'll learn a little bit about programming. So every language, or every microcontroller has a specific language that works with it. So we'll learn a little bit about the language that works with the propeller, and we'll get to write our first program today. So the program, we're actually going to get to write several programs, and they're going to focus on making some lights blink and using some loops. So we'll see how to do that. And we're going to do that using the language called Blockly, which is what works with our propeller. Okay? So any questions before we get started? All right, cool. So then let's review Cad Assemblies briefly. So a week ago, that's 2 classes ago, we talked about CAD parts, right? So a part was the sort of fundamental building block of computer-aided design. So that was just a single component that you created. And then last time, we talked about assemblies. So what was an assembly?
It was a collection of parts put together.
Yeah, exactly. So you could take 2 or more parts and put them into one file and tell the computer how they stuck together. Now, there were some rules that we gave the computer to tell that computer how these parts stuck together. Do you remember what those rules were called?
Constraints.
Yeah, constraints, that's right. So, so we can specify constraints to tell the computer how these things stuck together. In particular, last time we built a model of a car, kind of a very simple model like a toy car. So it had a body, 2 axles, and 4 wheels. So we used constraints to tell the computer that the axles should be connected in a certain spot to the body, and then also to tell the computer how to connect the wheels to the axles, right? So those were some simple constraints. There were different kinds, right? We could tell the computer that we wanted the axle to be inside the hole in the body, right? And then we could also specify how far that axle was protruding from the side. So that was called an offset. And then we could specify that we wanted the face of our wheel to be flush with the face of our axle. So that was a flush constraint. So there are different types of constraints that allow for different types of motion, things like that. Okay? So you start off by modeling parts, then you put them together using these constraints to create assemblies. And then once you have an assembly, you could use that to create a different kind of file, a presentation file, that allows you to do things like make animations and create exploded diagrams and things like that. So those were some of the fundamental abilities that we saw, that we learned about with CAD. Now there are many other things that CAD can do. For instance, it can do stress and strain analysis. So you could design an I-beam, for instance, in CAD, and then you could run a simulation to see how that beam would deform when you put a weight on the end. Or you could see, you could design a frame for a car and see how it would behave if you put the engine in different places. So there are many, many things that CAD can do. We just barely scratched the surface, but I just wanted to give you a taste of the CAD programs because in robotics, oftentimes you have arms or gears or things like that you need to design, and you'll often need to use CAD to do that. So hopefully by learning a little bit about what CAD can do, at least that'll give you some idea of a starting place if you needed to design something on your own. Okay? So any questions about CAD? That's the last time that we're really going to use CAD. We're going to hear lessons about CAD in this class. As we go on, you may decide that you want to design your own 3D printed parts to augment your vehicles. So you can use some CAD for that, but we won't be talking about it anymore in class. So any questions about that before we go on? Yeah.
So if we're going to be designing on parts or something, are there any resources that you can direct us to for how to do it more fully?
Yes, yeah. So I believe that I have some links on the Canvas page. So let me just double check. I should have some links there that could go on. You know, it looks like I haven't posted those right now, so I will make sure and post some links. There are many great tutorials out there that talk about CAD and go into much more detail than we have time for in this class. So I'll try and post some of those links to Canvas.
Furthermore, if we were to design and print ours out, do we do that here on campus, or is that something we have to
So
offshore?
So it depends. So there are libraries and things like that in our neighborhood that do some 3D printing. You can try that. We also have a design hub here on campus that does 3D printing. I think that they're pretty busy this semester is the only thing. So in past semesters we've been able to get some time on their printers, but I understand that they have a pretty heavy load this semester. So you might be able to squeeze in some time over in the design hub, or you might have to get it printed somewhere else.
So, where is it?
It's actually right here on campus. If you go out this door and just across the quad, it's right there. Oh, yeah.
311.
311, room 311. Thank you. Yeah. Other questions? Okay, cool. So then we're going to move on to a new topic today, which is microcontrollers. So first of all, what is a microcontroller? Basically, a microcontroller is a little chip that includes all of the components it needs to store and execute programs. Okay. So a microcontroller is a single computer chip that contains all components necessary to store and execute computer programs. So that's what it is. Why is it important? Well, every robot that's out there has some kind of electronic brain that determines how the robot behaves. And many robots use microcontrollers for their little brain. So we're going to learn about microcontrollers in order to learn how to control robots. Okay. So that's why they're so important. And 101 different varieties of robots out there, and each one is a little bit different. Many of them use microcontrollers, others use full-blown computers, things like that. But we're going to study microcontrollers in particular. So the reason for that is that basically every robot is controlled with some kind of program. Now, different robots use different languages, but fundamentally every robot is controlled by some type of program. So if you can learn the basic ideas behind programming, you can use those ideas to understand how to write programs and control robots. So we're going to use this particular microcontroller to learn about programming and controlling robots. And hopefully you'll be able to take those ideas and generalize them to control other types of robots. Okay? All right. So let's talk about what is inside of a microcontroller. We said that it's a chip that contains all the components it needs to store and execute programs. So let's talk about what those components actually are. So in particular, you have long-term and this is also called non-volatile memory. So this is a type of memory that allows you to store information even when the microcontroller is turned off or unplugged from power. Okay? So if you have some information that you need to store for a long time, you'll usually put it into non-volatile memory. So this is where computer programs are normally stored, because you want to be able to send that program over, and then you want the microcontroller to be able to run that program every time it starts up, even if it's been turned off, even if it's been unplugged. You want it to retain that program. Okay? So long-term memory is there. There's also a processor. The processor is the part that actually reads your program and interprets your instructions and then executes them. So it needs to be able to access the program in the long-term memory and pull that out, and then it needs to understand what those instructions mean. So, and it needs to be able to perform certain functions like arithmetic, like making decisions, like comparing things. So the processor has all of those abilities to read and execute your programs. And then there's also short-term memory. This is called volatile memory. And this type of memory only stores information while the processor, or while the chip is turned on and power is applied. Okay? So this is usually used by the processor to store information that it creates during a program. So for instance, if you add two things together and you want to remember the result, you would put that result into short-term memory, right? Because you need to know that while the program is running, but after the program is done or after you turn it off, you can forget about it. So the processor uses short-term memory to store information that's generated while a program is running. And then all microcontrollers have pins. So pins are these little metal connections from the chip to the outside world. So if you look at a chip, chips usually have little legs that stick out, and the more technical name for those little legs is pins. Okay? So a chip might have anywhere between 3 and 100 legs on it, depending on the variety of chip and what it's used for. So these pins serve many different purposes. Some pins are for power. So you need to connect power to the chip some way. So you have usually a power pin and a ground pin, and that way that's where the chip gets the energy it needs in order to run. Some pins can be used for communication with other devices. So when we send a program over to the chip, we're using certain communication pins to allow the chip to talk to our computer and read that program from our computer. So there's communication pins. Then there are also these special pins called input and output pins. And these are really what make microcontrollers special. Okay, so these are what set microcontrollers apart from regular computers. So there are several types of input and output pins. Some are digital. So input, output. That's also abbreviated I/O. So you might hear people talk about I/O pins. It stands for input output. So digital means something can only have two states, either on or off, high or low. So a digital input pin is a pin that allows the microcontroller to sense the outside world and measure a voltage and detect whether that voltage is high or low. Okay? You might also have an analog input pin that allows the microcontroller to measure a range of voltages. So you could measure something between 0 and 5 volts, for instance, and figure out what that voltage is. So these input pins allow the microcontroller to get a great deal of information. Yeah.
So sense outside world like temperature, is that what it means?
Exactly,
Or
exactly. So
can it be used for visual also?
Yeah.
Okay.
Yeah, so there is just a tremendous variety of sensors that are available. And these sensors can be connected to these I/O pins. So the sensors include things like temperature, light. You can measure force, you can measure distance, you can measure just a tremendous variety of things. Almost anything you can think of, someone's created a sensor to measure it. Okay? Gravity, magnetic north, all kinds of things. And you can use these input pins to connect your microcontroller to these sensors and gather that information. So you can read what temperature it is, you can read what the humidity is in the room, all kinds of stuff. If there's a sensor for it, you can usually measure it with these input pins. So that's one thing that sets the microcontroller apart from a regular computer, right? It's hard to connect a sensor to a regular computer. It's pretty easy to do it with a microcontroller. The other thing that microcontrollers have are output pins. So these allow microcontrollers to set output voltages. So again, you have digital and analog outputs. Digital can either be on or off, high or low. And then analog can be set over a wide range of values. So your microcontroller can use these output pins to control a large number of different motors and other kinds of actuators. So So that's how your microcontroller can make your robot move. Okay? So it can read information in from sensors through its input pins and then make a decision and then cause your robot to move based on that information. So for instance, you could have a camera that looks down at a work surface and takes a picture and captures an image of all the parts that are available on that work surface. And then the microcontroller could read that in and analyze that picture and figure out where each part is. And then it could send signals out to make motors move so that it moved an arm over a specific location to pick up a particular part. Okay? So this ability to gather information, process it, and then make decisions and move really is one of the fundamental abilities that robots have. Okay? So microcontrollers allow us to do these things. So that's why microcontrollers are so important, and that's why we're learning about them here in robotics. Okay? So questions about that? Okay, cool. So let's talk about the Propeller Microcontroller, which is the one that we're going to be using in this class. So the Propeller has all of these things that we talked about: long-term memory, short-term memory, processor, and pins. One of the things that makes the Propeller special is that instead of having just one processor, it actually has 8. And they all run simultaneously. So that means that you can do up to 8 things at once. So this is pretty cool, and we'll talk more about utilizing that starting next time. So right now we're just going to use one processor at a time, but starting with the next class, we'll see how we can actually use several of them to get even more benefits. So that's one of the things that sets this apart. The other thing is that we use the Blockly Prop programming language. So this is a programming language that's actually based on graphics. So most programming languages are based on text. So when you write a program, you write line after line of text. This has one major flaw, or one major drawback for people who are just learning to program, and that is that it's easy to make typos. So programming languages are notoriously picky about having exactly the right punctuation in exactly the right place. So you got to have exactly the right number of commas, you have to have the right number of brackets and braces, and if you miss just one of those, your program will fail to work. Okay? So what's nice about the Blockly Prop language is that the code is written with these icons, almost like Lego blocks. And you just drop one block after another to create your program. So since you are not typing out the program by hand, you don't have to remember exactly where to put the commas and the brackets. All of that is taken care of already. So it allows you to focus on the major ideas behind your program rather than getting bogged down with all of the little syntax details. So that's one of the reasons I really like the Blockly Prop language. So it allows you to focus on those things. Even for experienced programmers, I find that you're able to create programs pretty quickly because you're not spending so much time typing things out. So there's that. So, but some people are still diehard, coders. They like to write in a particular text language, and we'll see later that it's actually possible to use language based on C in order to write programs for the Propeller as well. And you can actually switch back and forth. You can write the code in the Blockly language, and then see how it would be interpreted in C. So it goes, it uses both styles. So, so that makes it pretty versatile. So let's take a look at the chip itself, okay? So this is one of the boards that we're going to be using in this class. Okay. So let me turn off another light so we can see a little better. So the Propeller Microcontroller, we said that microcontrollers are single chips. So the actual chip is just this part right here, this single black square. That's the chip. Everything else here are extra components that make it easier for you to work with this chip. But the microcontroller itself is just this single chip right there. Okay. So this is the chip. It stores all the programs on it. It has a processor there, and then these little metal wires around the outside are the pins. Okay. So I believe that this chip has 40 pins on it. Different types of chips have different numbers, but I think that this one has 40. Okay. So this chip is really the processor, the microcontroller, and then everything else around here are extra features that allow you to connect other things to the microcontroller. So the one that we're going to be using most is over here. So this white rectangle is a breadboard, and that allows us to make prototype electronic circuits. So you can connect them quickly and easily, and then you can disconnect them and reconfigure them. It's reusable. So that's very handy. In addition, you have some ports around the outside of this breadboard. So on the top, you've got these ports, and they say 5 volts over here on the right, and then 3.3 volts on the left. So those are power supply pins. So if you need 5 or 3.3 volts, you can connect them there. Down here on the bottom left is ground, so you can use those to connect your projects to ground. Over here on the left are pins labeled P0 through P15. That stands for pin 0 through pin 15. So those are digital input or output pins. You can assign each pin to be either an input or an output, and you can assign that in the middle of your program. So you could, in fact, you could have one program that uses pin 0 as an input, and then you could run another program and use pin 0 as an output. So you can switch those around. You can even have one program that starts with pin 0 as an input and then switches later to an output. Anyway, so those are digital pins. Then on the bottom far right it says AD. That stands for analog to digital. So those are input analog pins. So they measure an analog signal, an analog voltage from the real world, and then they convert it to a digital number that the computer understands. So those are analog input pins, and then these two, labeled 0 and 1 right there, say DA, that stands for digital to analog, so those are analog output pins. So,
I can't see that.
oh, I'm sorry, yeah, those are very small. Let me zoom in a little.
No, it's not, it's just a board.
Oh, the board, oh, sorry about that. Yeah, is that better?
Thank you.
Yeah, thank you for letting me know. Okay, so you've got these are your analog output pin I'm sorry, these are the analog inputs and these are the analog outputs, okay? So this board allows you to have all of those things. It's also got some extra features like this is a micro SD card reader. So you can read information from SD cards and store it to SD cards. This is a slot for special chips called Zigbee chips that allow for radio communications. And then over here is actually a VGA output, so you can even create television signals and things like that and send them out. So this, and then some of the most important things that we're going to be using in this class are up here on the top of the board. These are sets of pins that allow you to plug in motors. So you can connect servo motors directly to these pins, and they include power, ground, and signal wires for those servo motors. So that makes it easy to connect a servo motor and control it from this board. Yeah?
These things, they run hot, so have a lot of heat on them, or?
No, not really. No, we don't use a lot of power, so they don't get especially warm. Yeah. Other questions?
So, the switch there, that has 0, 1, 2,
Yeah.
that switches between different circuits on the board, correct?
Yeah, kind of. So this is the power switch. So 0 is off, and then 1 and 2 are on. So 2 turns on everything on the board. 1 turns on everything except the motors. So this is helpful if you are trying to program a robot that is on wheels. So if you're trying to do that, you usually put it on position 1 and send the program over, and then disconnect it from the computer and make sure that it's ready to go, and then switch it over to program 2 so it starts running. Yeah?
So is that a DC input connection, ground power supply on top, or?
Yes. Yeah, this is a DC power supply. It comes from a rechargeable battery. You can see it's also got a port for a 9-volt battery there. You can use that, but we use rechargeable batteries in this class. Yep. Other questions? Yeah.
Is it 12 volt or 9 volt or?
The rechargeable battery is nominally 6 volts, but really it goes up to like 7 or 7.5. So somewhere between 6 and 7.5. Now, that's another thing. The board only says that it has 5 volts here, but we're getting 6 or 7 volts coming from our battery. So what's happening is that there's something called a voltage regulator on here. Basically, the computer chip likes to have a very fixed, very constant voltage. So we don't want to have it hooked up to a battery where the voltage starts out high and then drifts down slowly as the power is used up. We want to have it hooked up to something that creates a very constant voltage. So that's what a voltage regulator does. It takes one voltage and then that might shift around a little bit and brings it down to a lower voltage, which is always constant and always steady. So you lose a little bit of voltage, but you gain a nice, steady, constant level. Okay? So that's another thing that's on this board. I think that is right there. I'm not sure.
So with regard to motors,
Mm-hmm.
because the motors are going to be of different voltages, how does the board work with motors that are beyond its 9-volt capacity?
Oh, so what happens is that this board is only designed to handle up to 9 volts, and so it's only designed to handle boards that or motors that run on up to 9 volts. it's possible to use this type of microcontroller to control much, much larger motors, but you need to add additional circuitry between the microcontroller and the motor to do that. So there are other chips that are designed specifically to do that. So there are chips called MOSFETs or IGBTs that are specifically designed to have a very low power input that controls them, and then they are able to switch and turn on and off some very high power, high current applications. Yeah. Other questions? Okay, so that's a little bit about the Propeller Microcontroller and the board that we're going to use. There are two different versions of this board. So you might get one that looks like this, or you might get one that looks a little bit different, but they all have the same basic features there. Okay? All right, so now let's talk a little bit about how we actually write programs for this. So I mentioned that that we're going to use this language called blocking. Okay, so let's talk about how this language works. This language is written in an online editor that is provided by a company called Parallax, the company that makes the boards and the chips. So,
And the robots.
and the, well, yeah, the chassis for the robots and the wheels, yeah, all the components. So, so in order to write these programs, you need to go to the Blockly website and sign up for an account. Okay? So that's the first thing that we're going to do when we get over to the lab. Everybody will go to this Blockly website and sign up for an account. And when you sign up, you want to make sure to remember your username and password, because we're going to be using these accounts for the rest of the semester. Okay? So make sure you put that somewhere safe. There's more detailed instructions on how to do that in the lab manual for today. Once you get to the Blockly website and you sign up, you'll come to a screen like this. And then what you're going to do is you're going to create a new project. So every program that we write is called a project, so we'll create a new one here. So we will call this light linker 2.4. You can call it whatever you want, but the board type is this Propeller Activity Board WX. And then you say finish, and then this brings you to a blank canvas where you can start making your program. Okay? So, like I said,
What was that last screen?
yeah, the Activity Board WX is the name. So, and that's listed out in the lab manual for today also. So the key to making programs here is that you find icons and you place them on your canvas. So the first thing that we're going to do is we're going to make a program that causes a little light to blink here. So you see this little light down there? Everybody sees it blinking on and off? So that's the goal for our first program. Just make a little light blink on and off. Right? Start simple, right? So fortunately for us, we don't have to write or create any circuitry to do this. The company Parallax thought it would be best to get people started easy, so they actually connected these lights to pins. So one of the little lights, let me show you this down here. So these little lights have numbers next to them. The one on the left says P26, The one on the right says P27. So to make P26 light up, all we have to do is set pin 26 to be high. To make it turn off, we just set it to be low, and the same for pin 27. So we can control these two lights just by making pins 26 or 27 high or low. Okay? So that's all we have to do there. So that makes it pretty easy to get started. So let's see how we can do that in our program. If we come over here to the left, these are all the menus that have the commands in them. So the control menu has a bunch of commands here related to control. The communicate menu has a lot of commands related to communicating. We want to turn a pin high or low, so we're going to go to the pin states menu. Okay? So, and then in this menu, there are all of these blocks. Each block represents a command. So I'm going to take this block and drop it on my canvas. And now this allows me to choose any pin that I want and then make it high or low. So I'm going to choose pin 26 and I'm going to set it to be high. Okay? So that's about the simplest program you can write. It's just got a single command, but it should still do something worthwhile. So let's try this out and see if it works for us. I'm gonna click this little run arrow here, this little down arrow, and that should run the program on my controller. So let's see if that goes. It said it succeeded, and now if I look at my microcontroller, I can see that that light is just turned on. So I set pin 26 to be high, that turns the light on. Okay? So our first program worked, right? Just a single command was able to do something interesting. So that's pretty cool. So now let's get a little bit more complicated. Maybe we want to make that light blink, right? So we could have it, in order to make it blink, it has to go on and off, right? So we also have to have it stay on for a certain amount of time. So I need my program to turn it on and then to wait for a little while and then turn it off. So in order to make it wait, I can come up here to control and then go and use this pause command. And it makes that satisfying little click when you snap things together. So, so now I'm turning my light on, I'm waiting, and then I want to turn my light off. So what I can do is I can right click on this command and I can say duplicate, pop it down there, and then turn it off. I'm going to make this low. Okay? So now I'm turning the pin on, waiting, and then turning it off. So let's send this over and see what it does. So I see the light go on and then go off, right? So far so good. But that only happens once. I want this to happen over and over again. So I need to use something called a loop, okay? So for those of you who are in my 302 class, we've done something very similar to this using a different language. So now you get to see same sort of project written in a slightly different language. Anyway, so a loop is something that makes your code repeat more than once. So we'll come up here to control, and we'll use this loop. It says repeat forever. Okay? So now I can drag my code in there
Snap together.
and run this. Yep, it snaps right together. Now, who thinks that this is... I think that there might be a little bit of a problem with this code. Let's see what happens when it runs. Okay?
It pause like on
So I'm running, it said it compiled successfully and it downloaded, but my light is just staying on. It's not blinking like I want it. So what's the matter here? What did I forget?
No delay on the off.
Yeah, exactly. So I'm turning the pin on, and then I'm waiting, and I'm turning it off, but then it loops back around and it turns it on again as soon as I've turned it off. So it's not off long enough for my eye to actually see. So I need to put another delay in there. So I'll duplicate that, put that down there. So now let's try this. Try this again. Goes on and off. There we go. All right. So now we've been able to make that pin blink. Okay? So far, so good. Now this is just going to blink forever and ever. But maybe I want to have it blink only a certain number of times, right? So it's actually pretty easy to do that. I can use the same loop that I was using before, I just have to make a modification. So instead of saying repeat forever, I click on this little menu and I choose X times. So now instead of repeating forever, it's going to repeat a certain number of times. Okay? But I haven't told it how many times yet. And in fact, there's this little cutout, like for a little puzzle piece, where it looks like something's missing. So in order to tell it how many times to repeat, I need to put something in there. So I'm going to come over here to my values menu. And in here, there are lots of different kinds of values. So there's numbers, there's words, there's binary, there's hexadecimal, there are true and false values. There's constants. So I'm going to choose this number up here at the top and plop that in. It fits right in there and it makes that nice clicking sound. And then I can type in the number of times that I want it to run. So I'll type in 5 here, for instance. Save that, send it over, and then we should see that light blink 5 times. Let's watch. 1, 2, 3, 4, 5. And then it stops. So that's how we can actually make it blink a certain number of times. Okay? So hopefully that gives you a flavor for how we can create programs using Blockly prop, this language. Yeah?
If you were to run 2 things at a time, would it be, in order to run 2 things at a time, would you just have 2 separate sections of the code sitting somewhere in that blank space?
Almost. So what we need to do if we want to run several things at once is we need to make functions.
Mm-hmm.
So a function is a sort of a program within a program. It's a small slice of code that can be reused and called by the program. So you would write a function for each piece of code that you want to run in its own processor, and you would call the functions. Yeah.
Such as if you were to write, if this value is true, then it would it can go back to another value, or it could be called back to another piece of code that you written earlier in order to act that out, or is that?
Kind of. So if statements are decision statements, and those are one topic. Functions are something different. So we'll talk about functions in a couple of classes. I don't want to get bogged down in it too much right now. Maybe we can talk about it in the lab. I can show you a little bit of that.
Okay.
Yeah.
If we wanted to look at the C coding, is there like a way we could toggle between?
Yes.
And just have a look see.
Yeah. Actually, it's pretty quick. So I've got this written out in Blockly. If I want to see the code, I just come up here and click on this button that says code. And then it switches right over. So this is how that program would look written in C. And so I can look at that, and then if I want to switch back, I just click on blocks, and it switches right back to the block view. Okay. Now, from this editor, you can only change things in the block view. So I can look at the code, but I can't edit it, right? I can't type in anything. So you make the program entirely with the blocks. You can only view it with the C code.
Could you use Blockly and convert to the C code and copy it and bring it onto an Arduino?
Not quite. So the Arduino language is also based on C, but it's a little bit different. It's just different enough that they're not compatible with each other. You can write a program in Blockly and then convert it to C, and there's actually a separate editor for the Propeller that allows you to edit C code. So you can make it in Blockly and then export it and then change it in that other editor and use that. Yeah. For this Propeller, but not for Arduinos. I think that there's actually a similar sort of environment that is designed for Arduinos that allows you to use sort of the same sort of graphical interface and make programs for those also. Yeah, other questions? Okay, cool. So let's do a quick preview of today's lab. So when you go to the home page for our class, you'll see on the left-hand side that there is an assignment section. So you'll go there, and then the assignment for today is the Blockly blinking LEDs. So you come here, and then there's a link to some instructions for the lab. So you go there and follow those. And then this gives you a little bit of background on microcontrollers, which is pretty much what we discussed in class. And then there's some instructions on how to sign up for a Blockly account, how to create a new project, and then how to write some programs. So in the instructions here, I introduced the idea of pseudocode. So pseudocode is kind of like a blueprint for programming. Basically, pseudocode is just text instructions that humans can understand. It's not for computers, but it's very useful for people because it allows a person to organize his or her thoughts before writing actual code. And it also can allow one programmer to design a program quickly and then give it to someone else to actually build. Okay? So I provide pseudocode and then I show an example of what the program would actually look like. So the first program you're going to write just makes a light blink. So this is the pseudocode. This is pretty much what we looked at a minute ago. So repeat forever, and then we make this light go on and off, and then it shows what the program should actually look like. So you'll do that, and we'll change it over and make it repeat just 5 times. And then the last part of the lab is a challenge. So you will create the message SOS. So
3 dots, 3 dashes, 3 dots, or is it 3
you got it, yeah.
3 dots, 3 dashes,
3
3 dots.
3 dots. So 3 short blinks, 3 long blinks, 3 short blinks. So for that, I show you the pseudocode, but I don't show you the actual program. Okay, that's going to be a challenge for you to figure out how to translate the pseudocode into an actual program that works. Okay, so that'll be the last challenge for the lab. And then once you have that complete, you need to upload your project to the Canvas website. Okay, so that's this interesting feature of another interesting feature of Blockly. You can actually you can save the project as a PNG, like an image file. Okay, so so I think we go download blocks file.
So if you do that SOS, you'd actually be stacking 3 of those together, correct?
Yeah,
All right.
yeah. So and we want it to repeat over and over again. Okay. So so when I download this, I get this SVG file, and an SVG is actually an image file. So if I open this, it opens just as an image. So it's an image that shows your program, but it's actually the program itself as well. So anyway, so it's both things, okay? So so you'll download that, and then you'll submit that to the Canvas website, and then that's what you'll be graded on, okay? So so that's the lab today.
So once again, that's saved as,
Yeah, so you
download blocks.
download blocks file. So you go,
Download blocks.
yeah, download blocks file. Yep. All right. So questions about that? Yeah,
Which one do we upload? Like
the blocks file, the SVG file,
it for the challenge also, or just the?
just the challenge.
Oh,
Yeah,
just the
the
challenge.
the SOS. Yeah. Mhm. Yep. Other questions? All right. Cool. Then I will take attendance and I'll let you go.